we focused our energy on identifying basic statistical terminology. In this lesson, we're going to dive into different types of data. And understanding data types is certainly crucial in statistics, I believe, for quite a few reasons. The data description, as an example, different data types have distinct characteristics that affect how they are summarized and described. Categorical data such as gender or occupation is typically summarized using frequency counts or proportions, while numerical data such as height or income is described using measures like mean, median, standard deviation. By knowing the data type, statisticians can choose appropriate summary statistics and techniques for analysis. We will talk more in depth about those different appropriate summary statistics in the upcoming lessons. The choice of appropriate statistical analysis techniques depends on the data type. For example, categorical data often requires different methods than numerical data. Categorical data may be analyzed using a chi-square test or logistic regression, while numerical data can be analyzed using t-tests or linear regression. Selecting the correct analysis techniques ensures accurate and meaningful results. Different data types also require different visual representations. Categorical data is commonly presented using bar charts or pie charts, which we'll learn about in an upcoming lesson, while numerical data can be visualized using histograms, box plots, or scatter plots, which we will tackle at the end of this particular unit. Understanding the data types helps statisticians choose the most effective and informative visualization technique to communicate insight and patterns effectively. Data processing is an important step in statistical analysis, and understanding data types is essential for this. Different data types may require specific data cleaning, transformation, or handling procedures. For instance, missing values in numerical data might be inputted using mean or median, while missing values in categorical data might be handled differently, such as creating a separate category or using a mode imputation. Data types influence how statisticians make inferences and generalize findings to a large population. The type of data collected determines the appropriate statistical tests and methods for drawing conclusions and making predictions. By understanding the data types, statisticians can ensure that their findings are applicable and valid for the target population. Therefore, understanding data types in statistics is essential for accurate data description, appropriate analysis technique, effective visualization, proper data pre-processing, and valid inference. It provides a foundation for making informed decisions throughout our entire statistical analysis process. So while some of that may be a little above and beyond the scope of what we're doing in class, there is a reason why we want to categorize data by the type that we're looking at. So we'll start off by talking about quantitative or qualitative data. We'll start with qualitative data. So to help fill in our blank, qualitative data, sometimes known as categorical, are the result of categorizing or describing attributes of a population. Now, when we talk about quantitative data, are always numbers. Quantitative data are the result of counting or measuring attributes of a population. So in the following examples, we want to discuss whether or not the following data are quantitative or qualitative. So if I think about different hair colors, we could be blonde, brown, brunette, red, purple, whatever color you want to dye your hair, of course. So all of these are different categories of colors. Now, of course, we certainly can count how many people would have a certain hair color, but the hair colors themselves are qualitative. Because we have different categories of hair color. The weight of a cow is measurable, so this is quantitative. The number of home runs in a game is also quantitative because we are counting how many we have. The education level that somebody has is qualitative, because there are different categories for the level that you have. Are you a high school graduate? Do you have a college degree? Do you have a post-secondary degree? Do you have a doctorate? Those kinds of things. Those are all qualitative. The time spent on a train is quantitative. We are counting how long we are on a specific mode of transportation. Your social security number. So don't be fooled here. A social security number is qualitative. Only one person has each social security number, and just because your social security number is a number, it's unique to you in yourself. It's only one person has each one. Now you could categorize perhaps different last 4 digits of a social, the first 3 digits of a social. You categorize how many in each of those categories, but they're categories of themselves. Our exam scores are quantitative. Because we count or we measure the score that we had earned. The temperature is also quantitative. We measure how hot it is outside or how cold it is outside. Once we decide whether we are qualitative or quantitative, we then want to decide if we are discrete or continuous. So in my little picture down below, we have qualitative data, which does not become either discrete or continuous. So if you have qualitative data, you do not need to worry about the secondary level. If you have countable data, it's either going to be a discrete data again is quantitative data that can be counted. And continuous data, again, is quantitative data that can be measured. Discrete data is usually data that we can count on our fingers, usually whole numbers, but not always the case. So let's see if we can identify some of the ones that we had above, if they are either discrete or continuous. So classify each of the following quantitative data. So we've already talked about the cow, home runs, time spent on a train, exam scores, and temperature. They are all quantitative data. The weight of a cow is continuous. The weight of a cow is continuous because we measure how heavy he is or she is, right? You put them on a scale and you can measure them. The number of home runs in a game is discrete. We count how many home runs there are. Time spent on a train is continuous. We are measuring how long we are on that train. We also can have fractions and or decimals. Exam scores are discrete. I could see making an argument for continuous, but it is considered discrete because they are typically measured and reported as whole numbers or specific categories. Discrete data consists of distinct and separate values that can be counted individually. In the case of exam scores, each score represents a specific value or category that cannot be further divided or measured as fractions or decimals. So if an exam scored out of 100 points, the possible scores would be integers ranging from 0 to 100. Each score is a separate and distinct value without intermediate values. A student's score could be 85, 63, or even 100, or any other whole number that's within the 0 to 100 range. There are no fractional decimal values in this case. Discrete data is characterized by its distinctness and lack of continuity. It is different from continuous data, which can take on any value within a given range, including fractions and/or decimals. Temperature, because you can have a decimal as part of your temperature, is continuous. It's measurable. We measure how hot it is or how cold it is outside. Then we want to talk about the levels of measurement. Data that is measured using a nominal scale, so there's some more vocabulary, is qualitative, that cannot be ordered. So qualitative data that is not ordered is nominal. We could also have an ordinal scale that is also qualitative, that can be ordered. And I have examples of both down below. Data that can be measured using a ratio scale is quantitative, because ratios again are numerical values, and has a starting point. Ratios can be calculated. Data that is measured using an interval scale instead is for quantitative data and has no ratios, cannot be calculated. So all of the topics that we had above, let's go through all of the different and determine the level of measurement given all that we know with each of the pieces. So we determined that hair color was qualitative because it was categorical. Since it's qualitative, we don't have to worry whether or not it's discrete or continuous. We just have to determine the level of measurement. Our hair color in and of itself, although it is categorical, it can't be ordered. There's no reason to order hair color. There's no importance to ordering hair color. And so therefore it is a nominal scale. All right, we determined that the weight of a cow was quantitative. We said it was continuous. And whether or not it has a starting point, a cow has a starting point. You can't have negative, right? It has a starting point at 0. You could weigh 0 pounds or 0 kilograms or whatever it might be. And ratios of cows can be calculated. Therefore, it is ratio scale. The number of home runs, again, quantitative. We said it was discrete. Home runs also, you start at 0. We have a starting point, and you can compare using ratios. So we're going to say this is a ratio scale. Compare different teams with their home runs. Education level, we said, was qualitative. So we can jump right to the level of measurement. Our categories are ordered, right? Because it's in order from least to greatest with respect to the least amount of education to the highest amount of education. So thus it is an ordinal scale. The time spent on a train, we said, was quantitative. And it was measurable, so continuous. And because we are able to compare using ratios, and the time spent has an exact starting spot at 0 minutes up into infinity, so we have ratioed. Social Security number, we said qualitative. And we're looking at the level. This is going to be nominal. The nominal scale, because it doesn't make sense to order the categories for any reason. Exam scores, quantitative. We said continuous. Discrete. I apologize, discrete. And because we can compare from, let's say, your first test score to the second test score, you can compare a group to a different group. We can have some ratios, or the ratio scale, I should just say. Temperature, we said, was quantitative. Continuous. However, this one is interval. It's typically measured using the interval scale rather than the ratio scale, because the 0 point in either Celsius or Fahrenheit does not represent the true absence of temperature. The interval scale allows for comparisons of temperature differences and the establishment of meaningful intervals between these values, but it does not have a true 0 point. In the interval scale, temperature is measured in units such as degrees or Celsius. The 0 point is an arbitrarily defined, meaning it is not a true absence of temperature. For example, 0 degrees Celsius does not mean the absence of heat, but rather the freezing point of water. Similarly, 0 degrees in Fahrenheit is not an absolute absence of temperature, but rather a point arbitrarily chosen as the lowest temperature he could achieve in his laboratory by Daniel Gabriel Fahrenheit. In contrast, the ratio scale has a true 0 point that represents an absence of the measured quantity. In a ratio scale, ratios and proportions can be calculated. For example, weight, height, and time can be measured on a ratio scale because they have a true 0 point. Since temperature does not have a true 0 point on the Celsius or Fahrenheit scales, it is more appropriate to use the interval scale for temperature measurements. However, there is an absolute temperature scale called the Kelvin scale, which does have a true 0 point called absolute 0, in which case can be considered a ratio scale. In the Kelvin scale, ratios and proportions can be calculated because the 0 point represents the absence of thermal energy. And that concludes the different levels of measurement, the difference between discrete and continuous data, and then quantitative or qualitative data.